Our lesson today is to be able to solve simple equations. The key ideas here are these properties of equality. The addition property of equality says that if you add the same number to each side of an equation, the equation remains true. All right. We have the subtraction property of equality, which says if you subtract the same number from each side of an equation, right, the equation remains true. It produces an equivalent equation. So we use those addition and subtraction properties of equality to solve equations. Here's our first example. It says some number when you take away 7 is equal to -6. Anytime we're solving equations, I always like for my students to identify the operation. Right? So I see subtraction. Because I only see one operation, it's a one-step equation. So we are one step from the solution. The inverse operation of subtraction is addition. So I'm going to have to add 7 to both sides of this equation. The equal sign splits the equation into two parts. You have the left side of the equation, you have the right side of the equation. On the left side of the equation, when you add 7 to -7, because they're opposites, that's going to become 0. So all that's left on the left side of the equation is your variable x. X is going to be equal to whatever's left on the right side of the equation when we add 7. -7 plus 6, that's going to be +1. X is equal to +1. You always want to check your answers using substitution, which means we want to replace the variable x with our solution of 1 and see if the equation is true. Alright, so I'm going to do the first example, but I'm not going to do all of the examples, but you should always check your work mentally. And here's what it would look like. We're replacing x with 1. We take away 7. Is that equal to -6? Is 1 take away 7 equal to -6? The answer to that is yes. So we know our answer of 1 is correct. Anytime you solve equations, you always want to check your solutions to make sure that your solutions are correct. Okay, our second example, we have some number when we add 3 4/10 is equal to 5/10. I see addition, and the inverse operation then would be to subtract. So I'm going to subtract 3 4/10 from both sides of this equation. On the left side of the equation, because these are opposites, that's going to be 0. So we're left with y is equal to whatever 5/10 take away 3/4 is. Well, how do you take 3/4 away from 5/10? Well, we're going to have to go to the side of our paper, and I have to subtract those two numbers, but I know that my answer is going to be negative, because when I use my rules for integers, if we have opposite signs, we subtract their absolute values, we take the sign of the higher absolute value number. So on the side of my paper, I take 3.4, I subtract my 5/10, alright, that's going to be 2, that's going to be 14, that's going to be 9, that's going to be 2. So we get 2.9, but I know my answer is going to be negative 2.9. And see if your answer makes sense. If we have negative 2.9 or 2 9/10 and we add 3 4/10, would we get 5/10? Sure we would. Alright, so problem number 2 is correct. Let's take a look at our next example. Problem 3 says some number plus 2 times pi is equal to 3 pi. Well, I see addition, and the inverse operation would be to subtract. So I'm going to subtract 2 pi on the left side of the equation. Whatever we do on one side of the equation, we have to do on the other side of the equation. So we're subtracting 2 times pi from both sides of the equation. On the left side of the equation, they're opposites. That's going to be 0. So we're left with h is equal to, well, if I have 3 times pi and I take away 2 times pi, I'm going to be left with 1 times pi, or just pi. Alright, let's take a look at some of these examples. Alright, we'll do each of these. We'll start with number 1. Problem number 1, we want to copy the problem. A number plus 2 is going to be equal to -5. When I look at this example, I see addition. The opposite would be to subtract. So I'm going to subtract 2 from both sides of the equation. They're opposites. That's going to become 0. B is equal to, well, -5 and -2. When the signs are the same, you add their absolute values, keep the sign the same. It's going to be -7. All right. Problem number 2. We have a number, take away 1 7/10. It's going to be equal to -9/10. I see subtraction. The inverse operation is going to be addition. So I'm adding 1 7/10 to both sides of that equation. They cancel. That's going to be 0. So I'm left with G is going to be equal to, well, I have -9/10 and I have +1 7/10. They're opposite signs, so I'm going to have to subtract their absolute value. So I'll do that over here on the side of the paper. 1 7/10. We have the 0 and 9/10, but I'm subtracting their absolute values. That's 0. That's 17. That's going to be what? 8. So we're left with 8/10, and that 8/10 is going to be positive because I have more positive than I do negative. So G is going to be equal to 8/10. That's problem number 2. Question 3. We have -3 is equal to a number plus 3. Well, I want to solve for K, so I have to do the opposite of this addition. So I'm subtracting 3. Or some teachers will say you're adding -3 to both sides of the equation. Either way is fine. That's going to be 0. -3 and -3. It's going to be -6. -6 is going to be equal to K. All right. Let's scroll down a bit, give ourselves a little room for problems 4, 5, and 6. Question 4. We have a number R, take away pi, is equal to pi. Well, I see subtraction, so the opposite is going to be addition. So I'm going to add pi to both sides of that equation. All right, they're opposites, that's going to be 0. So we're left with R on the left side of the equation. And on the right side of the equation, we have 1 pi plus 1 pi. It's going to be 2 times pi. See if that answer makes sense. If you replace the variable R with 2 times pi, is 2 pi take away 1 pi equal to pi? And the answer to that would be yes. All right, question 5. I'm going to do that a little bit differently, but let's copy it first. We have T minus 1/4. It's going to be equal to -3/4. Okay, because we have fractions, right? I still want to do the problem the same way. I see subtraction, so the opposite is going to be addition. So I'm going to add 1/4 to both sides of that equation. They're opposites, that's going to be 0. So we're left with T is going to be equal to -3/4 plus 1/4. Well, once again, you have opposite signs, so you have to subtract. So over here, you're going to do 3/4, take away 1/4, right? That's going to be 2/4. But because you have more negative than you do positive, the answer is going to be -2/4. If we simplify that fraction, that's going to be -1/2 for T. And then question 6. Question 6, we have 5 6/10 plus Z is going to be equal to -8. Right? That 5 6/10 is positive, so I want to make that a 0 by taking away 5 6/10 from both sides of the equation. That's going to be 0. Z is going to be equal to, well, my signs are the same here, so I have to add their absolute values. So that's 13.6. But because they're both negative, we keep it negative. So Z is going to be -13 6/10. Okay, we also have the multiplication and division properties of equality, which say you can multiply both sides of an equation by the same number, the equation remains true. Or you can divide both sides of an equation by the same number, right? The equation remains true. So we're going to use both the multiplication property of equality and the division property of equality to undo operations, right, to solve the equations for the variable. Okay, let's try some examples. Here we have -3/4 times the number is equal to -2. Well, the coefficient is the number that's multiplying the variable. So here the number multiplying the variable n is negative 3/4. So my coefficient is negative 3/4. It's a fraction. Well, this is negative 3/4 times a number. So the opposite of division, the opposite of multiplication is division. Whatever is multiplying the variable, that's what you're going to divide both sides of the equation by, negative 3/4. On the left side of the equation, negative 3/4 in the numerator, negative 3/4 in the denominator, they cancel each other out and that becomes 1. So you're left with 1n is going to be equal to negative 2 divided by negative 3/4. Well, that's going to become 2 over 1, and then when you divide by a fraction, you multiply by the reciprocal, so that's 4/3. Right? These are both negative. Negative times a negative we know is positive. So 2 times 4 is 8. 1 times 3 is 3. So we get 8/3 for our answer for problem A. Problem B, we're solving for x. So we have pi times the number x is equal to 3 times pi. If I want to solve that for x, I want to do the inverse or opposite of this pi times the number x. The opposite of pi times the number x would be to divide both sides of the equation by pi. Pi in the numerator is going to cancel pi in the denominator. You're left with 1x. Same thing here though. This is pi in the numerator. This is pi in the denominator. They're going to cancel each other out and you're left with 3. So x is going to be equal to 3. Right? And once again, we should be checking these answers, right? And you want to see if that answer makes sense. So let's check this first example, right? I should have checked this. If I replace n with 8/3, negative 3 in the numerator, or let's do negative 3 times positive 8, that's negative 24 in the numerator. 4 times 3 is 12 in the denominator. Negative 24 in the numerator, 12 in the denominator. That's going to give you negative 2, right? If I check my answer here, pi times 3 is the same as 3 times pi. So I always want to check your answers when you can. Alright, so let's try these examples here. This first equation says some number divided by 4 is equal to negative 7. I want to do the inverse or opposite of whatever operation I see here. So I see division. Well, what's the inverse operation of division? Multiplication. Well, what am I going to multiply both sides of the equation by? Whatever is dividing that variable, that's what we're going to multiply both sides of the equation by. So I'm going to multiply by 4 on the left side of the equation. I'm going to multiply by 4 on the right side of the equation. 4 in the numerator is going to cancel 4 in the denominator. We're left with y is equal to negative 7 times 4. It's going to be negative 28. Check your answer, see if it makes sense. If I replace y with negative 28, does negative 28 divided by 4 equal negative 7? Yes, it does. If I look at example 8, 6 times the number pi is equal to pi times a number x. If I want to get x by itself, I want to do the inverse of this multiplication of pi. The opposite of multiplying by pi is to divide by pi. On the right side of the equation, pi in the numerator is going to cancel pi in the denominator. That's going to give you 1. Right? So I write 1x is equal to pi in the numerator, cancels pi in the denominator. Right? That's also a 1. So we're left with 6. So x is equal to 6. All right? And then this last example here. We have 9/10 times the number w is equal to 1 8/10. I want to do the inverse of this operation here. This is multiplication. The opposite would be division. So I'm going to divide by my 9/100. I think I said 9/10. That was a mistake. It should be 9/100. So I'm going to divide by 9/100 on both sides of the equation. On the left side of the equation, 9/100 in the numerator is going to cancel 9/100 in the denominator. So we're left with w. W is going to be equal to whatever 1 8/10 is divided by 9/100. I go to the side of my paper. Here's 9/100, right? And I'm going to divide 1 8/10 by that 9/100. Slide 2 places. Slide 2 places. Decimal point in the quotient. 9 goes into 18 2 times. 2 times 9 is 18. Subtract to get 0. Bring down the 0. 9 can't go into 0. All right, so the 0 is going to go in our quotient, and we're left with 20. W is going to be equal to 20. All right? Okay. If we want to be able to identify if a number is a solution or not, we have to substitute and then see if the equation is true. So let's start with negative 15. All right? If I replace k with negative 15, let's see if we get something that's true. Is negative 15 plus 4 divided by 2/10 equal to 5? Well, we have to do this division first. So what's 4 divided by 2/10? Well, what's 4 divided by 2/10? I'm going to come over here to the side of my paper and do that. 2/10. 4, slide to decimal point. Decimal point goes in our quotient. 2 goes into 40 20 times. So is negative 15 plus 20 equal to 5? And the answer to that is yes. Right? So the answer should be question A. Right? Should be question A. All right? And let's see. Is that going to be it? All right. We do have one more example, the real life application. It says the melting pot of a solid is the temperature at which the solid becomes a liquid. The melting pot, the melting point. The melting point of bromine is 1/30th of the melting point of nitrogen. Write and solve an equation to find the melting point of nitrogen. All right. We set it up. We let N be the melting point of nitrogen, and I wind up with the following equation. Negative 7 is equal to 1/10 times N. All right. Once we write the equation, we have to solve the equation. Well, I see multiplication here. This is 1/30th times the number N. So the opposite of multiplication is division. So I want to divide both sides of the equation by that 1/30th. On the right side of the equation, 1/30th in the numerator, 1/30th in the denominator, they cancel each other out. That becomes 1. So I'm left with negative 7 divided by 1 over 30, which becomes negative 7 times 30 over 1, which winds up being negative 210 is equal to N. All right, and we're talking about degrees here. So it's negative 210 degrees would be the melting point of nitrogen. All right. Okay, and that should be our lesson for today. And I hope this is going to be helpful. Okay, we'll see you soon.